Hey there! How do we know which one is correct? Without much ado, or without much ado. I have eaten this morning, or I ate this morning. 7.23 or 7.23. Or the questions: how many bones does the human body have? How many arteries? How many veins? Well, if you're wondering about these answers, join the Learning Garage TV teaching program, screened live on Star TV, Channel 21, on Mondays, Tuesdays, Wednesdays, and Thursdays at 4 p.m. for delightful lessons on English language and mathematics. Repeat broadcasts are screened on the weekend. This show is proudly sponsored by Mercury International, the #1 betting company in Sierra Leone. Join us on the Outline Days for a life-changing experience.
Hello and welcome to Learning Garage. I'm your host, Gaira Babatunde Lamin. I'll be taking you through your learning session for today. And of course, we are looking at the current or the new senior secondary curriculum for Sierra Leone. And of course, this has been manipulated through the Ministry of Education and of course all through their experts that are currently in possession of our education in this country. Before we glide into our show for today, let's take a quick message from our sponsors and we'll be right back.
Hey there! How do we know which one is correct? Without much ado, or without much ado. I have eaten this morning, or I ate this morning. 7.23 or 7.23. Or the questions: how many bones does the human body have? How many arteries? How many veins? Well, if you're wondering about these answers, join the Learning Garage TV teaching program, screened live on Star TV, Channel 21, on Mondays, Tuesdays, Wednesdays, and Thursdays at 4 p.m. for delightful lessons on English language and mathematics. Repeat broadcasts are screened on the weekend. This show is proudly sponsored by Mercury International, the #1 betting company in Sierra Leone. Join us on the Outline Days for a life-changing experience.
Yes, welcome back. And of course, as we said just earlier, we shall be looking at a subject for today, and of course, which is the fundamental of mathematics. Okay, after the curriculum have been scrutinized, it was shaped into various disciplines under this particular subject matter, which is mathematics. And of course, the subject stream that we'll be focusing on today is mathematics and numerics. Okay, and we said the subject syllabus is based on the National Curriculum Framework for the Senior Secondary Education. It was prepared by the National Curriculum Specialist and Subject Experts. Okay, focus would be on Senior Secondary School 1, that is SSS 1, and second term topics. Okay, we shall be looking through our second term syllabus, and of course, right after the holidays, we shall be going through the second term. Okay. And the topic for today is what? Algebraic expressions. Algebraic expressions. And algebraic expressions, we are expecting students to be able to, after this lesson, what? 1, collect like terms, expand single brackets. Okay? You would be able to collect like terms and express single brackets. 2, you will be able to what? Expand double brackets, factorize algebraic expressions by linear factorization. You would be able to what? Again, handle differences of two squares. And addition to that, you'll be able to what? Handle quadratic factorization, group factorization, and finally solve word problems in context. Okay, this would be our focus in this particular lesson. After this lesson, I'm sure you will be able to. So stick by your television set and don't go away. Take your pen and your book and be ready for this lesson. We'll be coming back just after this short break.
This show is proudly sponsored by Mercury International, the #1 betting company in Sierra Leone. Join us on the Outline Days for a life-changing experience.
Yes, welcome back. And of course, this is the mathematics session, and we shall be looking at algebraic expression with your host, Gaira Babatunde Lamine. In algebra, we say letters are used to stand for numbers. Letters are used to stand for numbers. Normally, you see in the comic shows, they say, the comedian is saying, the teacher wrote on the board x plus y plus z, and you asked to find what? X. And everybody say, will shout, come on, this is x on the board. Or this is just a physical nomenclature, okay? We are looking at the mathematical aspect of things. Okay, you're finding the unknown. Something is yet to be solved. You're trying to find a solution for something that you don't know. Okay, that's why we use usually what we say when letters are used to stand for different numbers. They are called variables. We use these letters for finding variables. Okay, in other words, we say usually we use letters such as n, t, or x for our variables. What you don't know, you call it x. What you don't know, you call it y. What you don't know, you call it t. What you don't know, you call it n. So therefore, these are what we are going to be dealing with. And for example, we might say that S stands for what? The single length of a square. Suppose we have a square. Of course, square, it has all its sides equal, and of course all the dimensions are equal. Let's say we don't know the dimension of the square. We can say let x be the side of the square. Okay, from there you can take your story to a different level. Okay, now so when letters which have fixed values are called constants. Okay, what are constants? Constants are letters which have fixed values. Okay, for example, you have an expression 2 pi radius square where r and h are variables. Their values can change. Okay, 2 is a constant, pi is a constant, r is a variable, h is a variable. Okay, so where r and h are variables, their values can change. And of course 2 and pi are constant because they can never be changed. A 2 is a 2, a 3 is a 3, a 4 is a 4. Okay, so that's what we are saying. The values for 2 can ever remain the same as 2 until infinity. Okay, so where pi has an equivalent of 3.142 onwards, and therefore it is said to be what? A constant. An algebraic expression is a collection of letters and symbols combined with at least one of the operations addition, subtraction, multiplication, and division. Okay, these are the 4 types of operations that we'll be using to express our algebraic formality. Again, we say an algebraic expression is what? A collection of letters, symbols combined with at least one of the operations. The number on its own is called a constant. A number, example, 7 is called what? A constant. 3 is called a constant. 34 is called a constant. 1150 is called a constant. Okay? For example, in 3x minus 2y plus 5, the number 5 is the constant. Okay, we have 5 here as a constant, and note that a term consists of a number letters and powers of letters. Okay, the expression normally that we use is what is a combination of what? Three things. One, we say it consists of what? Number, letters, and what? Powers of letters. Okay, for example, the terms of 3x square y, 2y square plus 5x are, and 3x square y, where of course we have 3x square y as a separate term, 2yz as a separate term, and 5x as a separate term in all of the expressions, since they are separated by the signs. Okay, in a term, right, the number comes first. Whenever you have an expression, like example, which is given on the board, on your screen, 3x square y, 2y square plus 5x, okay? The terms are arranged in an organized fashion. That is to say, what comes first is what? The constant, followed by the variables, okay? But the variables are organized in what? In a way that they form alphabetical order. You cannot put y in front of x. You cannot put z in front of y, okay? You go through x, y, z, for example, okay? We say the number placed in front of and thus multiplying a letter or group of letters is called the coefficient. For example, we have a situation here where you have 7y, where 7 is the coefficient of y. 7 is the coefficient of y, where y is our variable. Okay. Also, in 3x squared minus 2y, we say 3 is the coefficient of x squared and minus 2 is the coefficient of y. Okay. The number that is standing, the constant that is standing in front of the variable is called what? The coefficient of that variable. Okay. Note that the plus or minus sign goes with the term which follows it. The constant, the coefficient always go with what? The signs. Okay. Now let's look at formation of algebraic expression. Forming algebraic expressions. Okay. The statements in words are often written as algebraic expressions in mathematics. Okay. The statements are gathered in a position that you have to form them in an algebraic expression. Any letters may be used for the unknown number, but a different number, a different letter must be used for each different unknowns. If you have an expression where you mention, they mention, or you have a problem where there are two unknowns mentioned in that particular expression, you have to separate the unknowns to be independent of each other. That is to say, you have expression where you have two unknowns. Example, I'll use x and y to differentiate the two unknowns. But you cannot use x for the different unknowns. Okay? X cannot be used for two different unknowns. Y cannot be used for the two different unknowns. You have to separate them. You have to separate them to their natural format. Simple logic is usually all what is required to translate a set of instructions into an algebraic expression. We are saying you have to think, you have to reason, you have to use common sense, okay? A man's age is X. The son's age would be in 15 years, how many years, okay? You have to use common sense, common logic, okay? Is what we're going to be expressing. Moving further, let's take example, basic examples. 1, we say X is a number. Write down an expression for a number which is A, 2 more than X, okay? you have a problem in front of you, we either say x is a number. What is the number? We don't know. We don't know the number. Okay, you have to write down an expression for a number which is what? A, 2 more than x. Okay, so if x is the number, that means 2 was added to that particular x number. Okay, so therefore this implies that what? A, we say 2 more than x, it means x plus 2 will give us the expression for A. Okay, that is A. B says what? 1 less than x. 1 less than x. So the number is x, and if 1 is less than that number, it means it's going to be, the expression will be x minus 1. I will say 1 less than the number x. C says what? 4 times x. Okay, C says 4 times x, that is x times what? 4. This gives us what? 4x. Okay, D says half of x. Half of x. Half of x means what? Half of x means half multiplied by x. This gives us x upon 2. Okay, x upon 2. Then the fifth one says 3/4 of x. 3/4 of x. 3/4 of x. 3/4 of x. Okay, this means that what? 3 upon 4 multiplied by x. This will give us what? 3 upon 4x. Okay, that is 3x upon 4. And the next one says 4 less than x. 4 less than x. Okay, let's take this off. 4 less than x. We have x minus 4. Okay, this will give us the expression. Okay. G says what? X less than 2 times x. X is less than 2 times x. This will give us x less than what? X less than 2 times x. X less than 2 times x. This will give us what? X less than 2 times x will give us x minus 2x, which is equal to what? 1 minus 2 gives us minus x. Okay, minus x. H says what? 3 times x less than 2 times x. 3 times x less than 2 times x. We take this off. This one says again 3 times x less than 2 times x. We'll have 3 times x less than what? 3 times x less than 2 times x. Less than 2 times x. 2 times x. This will give us 3x minus 2, which will be what? 3 minus 2 gives us 1, and you are left with what? X. Okay? But this is the expression for our word problem. Okay? I says 1/3 of x less than x. 1/3 of x less than x. 1/3 of x less than x, that is I. 1/3 of x less than x. Okay, This will give us 1 upon 3 multiplied by x minus x. That is to say we have x upon 3 minus x. This gives us 1 minus 3x all upon 3. Okay, so this will give us what? Finally, it will give us this particular expression. Okay, and the J says what? 1/5 of x more than 6. We take this off. J says 1/5 of x more than 6. 1/5 of x more than 6. J, 1/5 of x more than 6. Okay, so the expression would be 1 upon 5 multiplied by x plus 6. This gives us what? X upon 5 plus 6. Okay, this would be your expression. Okay, so there is an exercise for you to try. There is an exercise on your screen to try. Give you small time out for you to take down the necessary information, and we will be right back.
This show is proudly sponsored by Mercury International, the #1 betting company in Sierra Leone. Join us on the Outline Days for a life-changing experience.
Welcome back to Learning Garage with your host Gaïa Babatunde Lamine, and we are looking at the algebraic expressions for Senior Secondary School 1, second term. Okay, our next focus would be on operations on algebraic expressions. Operations on algebraic expressions. How do we handle algebraic expressions using what? The different rules that we apply to have our expressions. We say the 4 rules of addition, subtraction, multiplication, and division can be used to simplify algebraic expressions. It's as simple as that. We use 4 different modes of operations: addition, subtraction, multiplication, and division. These are what we use to simplify algebraic expressions. We focus on the first 2, addition and subtraction. We say only like terms can be added or subtracted to give a single term. Again, only like terms, the one that we fiba, and that we use for add or subtract, so that these can give us what? A single term. This is often called collecting like terms. Yeah, most of the time the teacher says, let's collect like terms, let's collect like terms. Orange for oranges, mango for mangoes, banana for bananas. You cannot mix bananas and mangoes. It cannot be allowed in mathematics. Okay, so therefore what do? You separate the terms from which therefore you can collect what and what are likeable. Okay, so therefore we say only like terms can be added or subtracted to give a single term. This is often called collecting like terms. Expressions often contain several sets of like terms. It is easier to simplify if you rewrite the expressions with the like terms next to each other. You have 2x plus y plus 3x minus y. It's easier to group x and x, y and y within the expression, so it can be simple for us. Let's take an example. We are asked to simplify the following algebraic expressions A, B, C, V, and so on, using so and so and so variables. Okay, let's add our slides. Okay, let's look at the first example, A. You have to simplify the algebraic expression A, which gives us what? 22x minus 4xy minus 7 plus 3y. Let me transfer it to the other part of the board. You are given 22x. A says 22x minus 4y minus 4xy minus 4xy minus 7x plus 3xy. Okay? You're given 22x minus 4xy minus 7x plus 3y. Okay? We say the first thing you have to do is what? You collect like terms. The terms, there are two different terms there, which are x and xy term. So we group x terms together and also the xy terms together. That is to say, this gives us what? Our 22x, and the other x term there is minus 7, minus 7x, and we'll move on to the next term, which is 4xy. Okay, that will be minus 4xy plus, what term is left there? 3xy. Okay, you are left now with 3xy added to the particular expression. So if we simplify further, that is to say, we operate, we'll have 22 minus 7x and minus 4xy plus 3xy. So 22 minus 7x gives us what? 15x. Then minus 4 plus 3 gives us what? Minus xy. Okay? This will be our final expression for A. Okay? Our final expression for A, this will be our answer. Now we move on to the B part. The B part says what? We have 14y minus x plus 2y minus 6x plus 5 minus 5y. Okay? So we do the same for B. B says what? The B part says 14y minus x plus 2y minus 6x minus 5y. Okay? So again, it's simple and straightforward. You collect like terms. That's the first thing you do. Before adding or subtracting, you have to collect like terms. The like terms there are what? We collect the x terms first. We have minus x, minus 6x, then plus 13y, minus 5y. Okay? So minus x minus 6 gives us what? Minus 7x. Then 14y minus 5 gives us what? 14 minus 5 gives us 9. That is going to be, they say, the larger number carries a sign. larger number carries a sign, it will be 9y. Okay, this will give us our expression for B. Okay, move on to C. We move on to C. C says what? 2n plus m plus 9m minus n minus 2m. Okay, we write our expression. C says what? 2n plus m plus 9m minus n minus 2m. Okay, so again, it's simple and straightforward. It's as easy as drinking water. We say we collect like terms. First, you collect like terms. There's no need to panic. Okay, you have 2n, you have two different terms. Okay, within the expression, you have n and m. So you collect n on one side and m on another side. Okay, we have 2n plus m plus 9m minus n minus 2m. N for n, so we have 2n minus n plus m plus 9m minus 2m. Okay, so this gives us what? Now we can add or subtract our coefficients. The coefficient of n for the first term, 2n, is what? Is 2, and the coefficient of our minus n term is minus 1. So therefore we say 2 minus 1 gives us what? 1. But we don't write the 1, we write, of course, our n. It stands alone. It's wrong for you to put there 1. Okay, it is plus 1 already, n standing on itself. Okay, so we move on to the next terms, which are m. So we have plus m plus 9m. So 1 plus 9 gives us 10, minus 2 gives us plus 8. So therefore we have plus 8m. Okay, this is our final expression for C. So move on to the next one, which is D. Our D says what from the expression? D says minus 18. This says 18D minus 8E minus D plus 2E. Okay, we write the expression again. Please make sure you write the. This says what? 18D minus 8E minus D plus 2E. Okay? Again, we follow the same simple rules, which says what? We are to collect like terms. From there, you can go through your operations. We have D and E. So D for D, E for E. So therefore, this gives us what? 18D minus D minus 8E plus 2E. So 18D minus D gives us what? 17D. 18 minus 1 gives us 17. 17 is the coefficient and our variable there is D. We are done with D. We'll move on to the next term, which is E. We have the coefficient of our first term for E, which is minus 8, and the coefficient of our second term for E is plus 2. So therefore, we'll add or subtract 8 minus 8 plus 2 gives us what? We subtract, which will give us 6, and we take the sign of the bigger number. That is what normally we say, okay? That is the rule. Okay, the sign of the bigger number there is 8, so therefore it will be minus what? 6e. That is all you need to do. Okay, this will be your final answer for D. Move on to E. Expression E. What does E says? E. Our E says 2C plus 5C. 2C plus 5C minus 9C. Okay. 2C plus 5C minus 9C. Because this is as straightforward as it looks. So all for C's, yeah? C for C for C. C for C. This is what we have. C for C. So therefore we'll have 2C plus 9 for plus 5C minus 9C. 2 plus 5 gives us 7, and 7 minus 9 gives us what? Minus 2C. So this will give us minus 2C. Okay? That is all for E. And we look at the other expression which says F. F says what? It says what? F says 7K minus 2K, 7K plus 2K minus 6K. You have to be careful with the signs. One sign on copying gets your whole expression wrong. Okay? This is all for K, K for K. Okay, you have 3 K's there. You have 7K plus 2K minus 6K. So we either add or subtract all the coefficients of the values of K. So we have 7 plus 2, which is what? 9. 9 minus 6 gives us 3K. So 9K minus 6K gives us 3K. Okay? This is all you need to know. We look at the next last two ones, which are G. Our G says what? Our G says 6A plus 7A plus 8A. So this is triple A for A. Okay? We have 6A in the expression plus 7A plus 8A. This is basic addition. We use our calculator. So we say 6 plus 7 plus 8 gives us what? 21. Okay? So therefore we'll have 6 plus 6A plus 7A plus 8A gives us 21A. Okay? 21A. Move on to the next one. The H says what? H says 2B plus 3B. Okay? 2B plus 3B. Double B. Okay? Double B's here. So therefore, the expression will be what? Adding the like terms of our expression or the variable B. So that would be, what is the constants? What are the constants in front of the B's? Are what? You have plus 2 and you have plus 3. So therefore, adding them together gives us what? 5B. So this 2B plus 3B gives us 5B. This would be as simple as anything you can ever imagine. Okay? There is an exercise for you to quickly glance, and of course you practice in a little corner. We'll leave you with this exercise and go for a quick break. When we come back, and we shall discuss more. Stay tuned to Star TV.
This show is proudly sponsored by Mercury International, the #1 betting company in Sierra Leone. Join us on the Outline Days for a life-changing experience.
Welcome back. This is Learning Garage, your mathematics session with me, Gaya Babatunde-Lamine. We are looking at algebraic expressions for our SSS1 students for the second term. Okay? We continue with our expressions. Now we are going to look at the operation at multiplication and division. Already we've discussed and we've looked at examples dealing with addition and subtraction operations. Therefore, we are going to the operation of multiplication and division. Okay? We say multiplication and division when multiplying or dividing expressions, it is easier for you to group the numbers and the same letters together and then use basic rules of indices. Okay? You have to know your indices, where you have two different bases. What do you do with the powers? What do we do with this and these expressions? Blah, blah, blah. This is all what you need to do, okay? That's why mathematics is all about foundation. So without wasting much time, we say, wait, again, when multiplying or dividing expressions, it is easier if you group the numbers and the same letters together and then use the basic rules of indices. Note that a bracket may be used to show a multiplication. For example, that is A multiplied by BC. This means you have to multiply A by the expression or the terms within the bracket, which are B and C. Okay? A times BC definitely will give us ABC. Okay? You are learning ABC. Let's look at some examples, basic examples. Okay? You asked, you say what? You asked to simplify the following expressions. Simplify the following expressions. You have I, which says 1, which says 4p multiplied by what? Our 8p. Let's look at the solutions for this. Okay? Yes, let's look at the first example, which says I. Our I there says, our first one, 1. 1 says what? 4p. 4p multiplied by 8p square. Okay? 4p multiplied by 8p square. This implies that according to the law of indices, when we have the same base, okay, what do you do with the powers? First of all, you have to multiply the coefficients of p. The coefficient there are what? Of the variables there are 4 and 8, okay? You have 4 and 8 as the coefficients, 4 and 8. You multiply those ones, and then what do you do with the expression of p as the base here? So when there is a multiplication sign in between the same bases, what do you do with the powers? You add the powers. So this means you have 4p multiplied by 8p square. This gives us what? 4 multiplied by 8 gives us 32. 4 times 8, 32. P. What do we do with the powers? You have plus 1 here. There is a plus 1 here. This is 1. So therefore it will be 1 plus 2 gives us what? 3. So our power here would be 3. Okay? So therefore again, if you have 4p multiplied by 8p square, you multiply the coefficients of the variables, which are 4 and 8. 4 times 8 gives us 32. 32p. Then, what do you do with the powers? You add the powers because there is multiplication in between the bases. So when the bases are the same, with with the sign of multiplication in between them, you add their powers. Okay? The second one says what? The second one says minus. The second one says minus a minus 2a multiplied by 4. C multiplied by 5b. Okay, minus 2a multiplied by what? 4c times 5b. Okay, this is as simple. All you need to do is to multiply all the coefficients of your variables, and then you merge the variables. Okay, that is to say the coefficient of the variables are there what? Minus 2 plus 4 and plus 5. So if you say minus 2 multiplied by plus 4, it gives you 8, and 8 multiplied, that is minus 8 multiplied by 5 gives us what? Minus 40. So therefore, we have the right to say minus 2a multiplied by 4c multiplied by 5b gives us what? Minus 40. What about the variables? All you need to do is to download the variables. Okay, you have a, b, and c in alphabetical order. Okay, in alphabetical order. So therefore, the expression will sum up to minus 40abc. 40abc minus 40abc. Let's look at our next example. 3. The third one says, third one says 1, 2, 3. It says 5x y square multiplied by 4x to the power 4 y to the power 3. Okay, so we have the third one, which says 5x y square multiplied by 4x raised to the power 4 y raised to the power 3. Okay, that is y cubed. So how do we go about this one? This one is simple. Again, we multiply the coefficients of the variables. There are two sets of variables there. You have x and y, but these have different powers. The variables have different powers. That is the second part of the solution. The first part of the solution is for you to what? Multiply the constants, which are the coefficients of the variables. We have two coefficients of the terms, two separate terms, which are what? Plus 5 and plus 4. So therefore, if we multiply 5 by 4, this gives us what? This gives us 20. Gives us 20. And then what do we do with the powers? What do we do with the powers? Remember, indices says when you multiply a single or the same base of an expression, when there is a multiplication in between them, you add the powers. So x multiplied by x to the 4 gives us what? X to the 5. That is to say 1 plus 4 gives us 5. Okay? So instead of x multiplied by x raised to the power 4, we have the right to say x raised to the power 5. Okay? Then we move on to the y. Y times y gives us, of course, y. And then the powers there, it would be what? 2 plus 3 gives us 5. Okay? So this would be your expression. 5xy square multiplied by 4x raised to the power 4 multiplied by y cubed gives us 20x raised to the power 5 multiplied by what? Our y raised to the power 5. Okay? Move on to the next example. Example 4. Example 4 says what? 16a cubed b square divided by 2ab. Okay, 2ab. 16a cubed multiplied by what? Divided by 2ab. This is the same as we writing again as 16a cubed b square. Okay, it can be the same as 2 upon all upon 2ab. Okay, it can be written in that format. Okay, so we say again, there is the operation sign there is division. So therefore, what do we do with the coefficients of the variables? We divide the coefficients of the variables. 16 divided by 2 gives us what? 8. Okay, and then we have our a. What do we do with the powers? We subtract the powers of a. That is a raised to the power 3 minus a raised to the power 2. That is to say 3 minus 2 minus 1 gives us what? 2. Okay, this will give us what? 8a square b. And for our b, we subtract the power. We subtract the powers. That is 2 minus 1 gives us what? 1. So this ends up, we have 8a square b. That is all for that one. We move on to the fifth one, the fifth example. Fifth one says 15y cubed divided by 3y square. Okay, 15y cubed divided by 3y square. So again, the operation there is division. So what do? We divide the coefficients. 15 divided by 3 gives us what? 5. So this expression becomes 5y. What do we do with the powers of y? We subtract the powers of y. So therefore we end up having 5y. Okay, it's as simple as that. Then the next one, or the last one, says 15. I think that is the last one. Okay, we jumped on the fifth one, which says 2st cubed multiplied by 4s squared t. Okay, let's handle that. The last one, which says the fifth one there, actually, which says 2st cubed multiplied by what? 4s raised to the power 4 t squared. Okay, so again, since the operation there is multiplication, so we multiply 2 and 4 gives us 8. And what do we do with the bases? Okay, since we have the base of s, we add the powers. That is 1 plus 4 gives us 5. That is s raised to the power 5. And t, its powers would be 3 plus 2 gives us what? 5. Okay, so that would be all. And I'll leave you with a series of examples or exercises for you to practice at home. I'll leave you with these examples, okay, on your screen. Remember, this is Learning Garage, and this is proudly brought to you by Mercury International, the #1 betting institution in Sierra Leone. Stay tuned, always 24/7. Stay glued to Star Television, the #1 broadcaster in Sierra Leone. It cuts across all the parts of Freetown, all the parts of the country. Okay, so I'll leave you for today. Thank you very much. I've been your host, Gary Babatunde Lamin. Tata.
Hey there! How do we know which one is correct? Without much ado, or without much ado. I have eaten this morning, or I ate this morning. 7.23 or 7.23. Or the questions: how many bones does the human body have? How many arteries? How many veins? Well, if you're wondering about these answers, join the Learning Garage TV teaching program, screened live on Star TV, Channel 21, on Mondays, Tuesdays, Wednesdays, and Thursdays at 4 p.m. for delightful lessons on English language and mathematics. Repeat broadcasts are screened on the weekend. This show is proudly sponsored by Mercury International, the #1 betting company in Sierra Leone. Join us on the Outline Days for a life-changing experience.